Right, let's move on with this section on trigonometry, where we are interpreting these graphs. It's usually at the end of your question. It's important that you should understand it. This one says solve for x. It's important that you should know what we're looking for, x. If f of x is less or equals to g of x, where x is an element of minus 90 and 0, the restriction has changed. Now we're looking at those two graphs between minus 90 and 0. Where is that region? Minus 90 and 0. We are only concentrating on this, on this region, not the whole parts of the graph, only that one, between minus 9 and 0. Now that makes our lives easier. If we're looking at the two graphs all in everywhere, we're going to go beyond, but we've got to concentrate between minus 9 and 0, which makes life a bit easier for us. Now solve for x if f of x is less or equals to g of x in this region. Now there are two things here, where f is less and where f is equal. I know where f is equal to g. It is where the two graphs intersect. Where the graph of f is equal to the graph of g, it is in 5 places. It is in 1, 2, 3, 4, 5. But are we looking for the whole region? No, we only concentrate between minus 90 and 0. So where are the two graphs equal in this region, between minus 90 and 0? Between minus 90 and 0, where are the two graphs equal? At this position and that position only. We're not concerned about what's happening beyond 0, because the restriction says we must start from minus 90 up to 0. Right, so that's how we tackle the first part of the equal sign here. What is the less than? Less than, less than. If I've got, I think Zulu will explain this better. Where f less than g, I say lapho khona f engaphansi kuka g. If I've got these two dusters, look at this one and look at this one. Duster A, this one is duster B. Which duster is above which one? Why duster ngaphezulu? Duster A noma duster B? Which one is above? It's difficult to tell. But if I bring them closer, I can tell which duster is above which one, because I'm comparing them in terms of their height. This one is above this one. So that's exactly what we have to do here. In other words, we need to create some sort of stripes in our head. So whenever I'm talking about this point here, I create these stripes in my head. This will help me. We're looking for the position where this graph is less than this graph. In fact, it is less or equal. I'm just concentrating on the last part of it for now. Which one is f? Yes, f is the yellow graph. This one is f, so that one makes it a g. It is important that we should label our graphs at all times. If this is f, that is g. Make sure that you label your graphs as well. While the position where f is less than g, where f engaphansi kuka g, f umuphi f? F, it's the yellow one. This is the f, the yellow one. Sifuna lapho igraph yethu ingaphansi kuka g, f engaphansi, f is less than g. Now, when you compare the graphs, if I look at this point, I compare it with the point slightly directly above it. Looking at this graph and this graph, f lo g la. But into sifunayo thina sifuna lapho f engazansi noma ilingana no g. F lo g lo, ubani ongezansi? G lo, f lo. In this particular case, ubani ongezansi? G. Sifuna kuthina la g engezansi noma la f khona engezansi, la f khona. So at this position, it's not part of our solution. If I take it to this solution, usangaphezulu f lo simfune ngezansi. At this position bayalingana. So from here, it's part of our solution. Usenjani ke manje f la usengezansi. In other words, we are looking for where the yellow graph is below the orange graph. So let's look at that position. So this one, isingaphezulu le isingezansi. That's the position that we are looking for. So it is below at this side. Ngale isingaphezulu, asayifuni la ingaphezulu khona le. Ingaphezulu balingane la bese iba ngezansi la. Balingane la bese iba ngaphezulu. We don't want the one on top, but we want now below. If we were looking at the whole graph, this is what we're going to be our solutions. This side, that side, and this side. But fortunately for us, it says we should only show between minus 90 and 0. If we're showing the whole region, we're going to have 3 different solutions here, here, and there. But in this particular case, in this particular problem that we are doing there, we only have to show between 90 and 0. So this is the position that we are looking at. So how do you write the solution here? Remember here, we want the solution where they are equal. We also want that solution where they are equal. So we're looking for the values of x in all that region. What are the values of x? So how do we write it? We say our x is an element of, where does it start? It starts from this position. If I did not know what the value of this position, I was going to experience problems to locate the value of x here, because we got them from our first diagram, from our first part when we were doing this algebraically. So we know that value, it is minus 67,5. So I can write the solution. Without understanding that first, it will be difficult for us to understand this one. So our x starts from minus 67,5. So it starts from minus 67,5 up to what? This goes up to this value. Do I know this value? Yes, it is minus 45 degrees. It is minus 45 degrees. You close this bracket. Now watch here. What if this question did not have this sign? What if it was just f of x is less than g of x? Where these boundaries were not included. These were not included. Now, the types of brackets were going to be different. If I was doing the same thing, but this was the graph, this was the instruction, the answer was going to be x is an element of. You use the round bracket when this is not included. When this value here is included, you use the square bracket. Since both these values are included, that's why we are using the square brackets. But if those are not included, we use the round bracket, something inside that bracket, which will be minus 67,5. It will go up to minus 45. But 45 is not included. 45 is not part of the solution because there's no equal in this particular case. But once we have equal, we're saying we are including the 67. This bracket simply says it starts from 67. This one says it's end at 45. This one is saying it's end just before 45. Just before 45 will be our solution. Just before, just after 65. Here, 67 is included, and as well as minus 67 is included, as well as minus 45 is included. If we did not have this restriction, if we had the same restriction as that one, we're going to write this as the solution as well, as that one as a solution. But this is not the only notation we use. We call this the interval notation to represent the solution. The same solution can be represented in another solution, which we refer to it as the set builder notation, where we say x is greater than, look here, x is greater or equals to, what is the value there? It is minus 67,5 degrees, or x is less or equals to 45 minus 45 degrees. You can represent it, your solution, in this notation, which we refer to it as the set builder notation, or you can represent it in this notation, which we call it the interval notation. Thank you.